Today our focus was going to be characteristics of a function, so I will make this a very quick video for you to be able to review and be able to do your homework. Linear versus nonlinear functions. Linear versus nonlinear is just as it sounds. Does it form a straight line or does it not form a straight line? So we want to look at a couple of examples of each. Linear equations are your y equals mx plus b, y equals mx, or y equals kx. Remember, we talked about those the other day in class. These are all of the equations that you have used thus far in class. Your focus last year was on direct variation, and that used the y equals kx form, but you were also exposed briefly to y equals mx and told that you'll be exposed more in detail to y equals mx plus b this year. The equation y equals x squared plus 3 is going to create a curved line. Since it will create a curved line, it will not be linear. The equation y equals 4 times x to the third power will also create a curved line. So it would also be nonlinear. Now we'll notice the big difference between these two equations, the linear and nonlinear. The linear equations have x to the first power. Your nonlinear equations are going to be x to the second power, x to the third power, x to the fourth power, and so forth. They'll also be your square root equations. Now, we could graph this equation, and you'll notice that there's a straight line, and this straight line is not going through the origin, so it does not have direct variation, and it also is not proportional. We'll talk about those more in depth as we start getting into y equals mxb equations, but right now we just need to recognize that it is in fact a straight line, and so it would be linear. As opposed to this quadratic equation does not form a straight line and is thus classified as nonlinear. If we looked at a table, it would be important for us to realize that as each x value increases by 1, my y value increases by a direct constant rate of change. So in this instance, the y value is increasing by 3. My x value changes from 1 to 2, another distance of 1 unit. My y value changes from 5 to 8, another distance of 3 units. My x value increases from 2 to 3, another distance of 1 unit. My y value increases from 8 to 11, another increase of 3 units, and thus forth. So as long as our constant rate of change is consistent among each of our transitions from x's and their associated y's, we're going to end up with a linear equation, or a linear function. A nonlinear function is going to mean that our y's will not necessarily change proportionally to our x's. So in this example, we go from 0 to 1, and we'll notice that our y's increase by 1 unit. When our x's go from 1 to 2, our y's increase by 3 units. When we go from x of 2 to 3, our y's increase from 7 to 12, which is 5 units. And so we can see some sort of exponential growth happening there. So let's practice. Is the graph linear or nonlinear? Well, A is obviously not a straight line, so it would be nonlinear. B is a straight line, so it would be linear. C is a straight line, so it would be linear. It's also going to be important for the EOG for us to go ahead and remember this line is straight and goes through the origin, so it's not only linear, but it's also proportional, and it has direct variation. D is again a curved line, so that would be nonlinear. Again, we want to be able to identify whether they're linear or nonlinear from a chart. So we want to look at the relationship between our x and our y's. Starting with our x's, our input, 1 to 2 is a change of 1 unit. Our output, y value, changes from 1 to 4. That's a rate of 3. Our x value for our next set of pairs, 2 to 3, that changes by 1 unit. Our output, 4 to 9, that's 5. So no, we don't have a constant rate of change. So this is going to be nonlinear. Our chart on the left, 1 to 2, is our input. change by 1 unit. Our output changes by 2 units. Our input 2 to 3 changes by 1 unit. Our output 4 to 6 changes by 2 units. We do have a constant rate of change, so it will be linear. The chart on the right, 1 to 2 is a change of 1 unit. 2 to 5 is a change of 3 units. 2 to 3 is a change of 1 unit. While 5 to 11 is a change of 6 units, so that's not going to be linear. Tell whether the function shows a linear or nonlinear relationship. Y equals x squared minus 1. Obviously, the x squared is going to create a nonlinear equation, as we discussed earlier. Y equals 2x minus 4 follows our y equals mx plus b form. X is raised to the first power, and so it will create the equation of a line which is linear. Independent versus dependent variables. An independent variable, and this would be good probably to jot down in notes, is a variable that does not depend on any other variable. We qualify this as the x variable. The most common independent variable that you'll see is time. And we'll talk about that a little bit more when we see the subsequent graphs. The dependent variable is a variable whose value depends on some other value. Our y values always depend on what x value we previously select. And we've done that a little bit when we created t-charts, and we'll continue to do that more as we create t-charts in the upcoming units. So for example, name the independent and dependent variable. A painter must measure a room before deciding how much paint to buy. So the independent variable are the measures of the room. They don't depend on anything else. They simply are what they are. The dependent variable is how much paint to buy. The amount of paint that we're going to buy depends on the measurements of the room. If my measurements are small, I need very little paint. If my measurements are large, I'm going to need quite a bit of paint. So we want to be able to also look at graphs and name the independent and dependent variable. Now, I already told you that time is your independent variable, but we also recognize that time is sitting down on the x-axis. So when we're looking at a graph, we can realize right away from looking at the x-axis that is our independent variable. So in this case, our dependent variable is the water level. We can look at the graph and then read it or interpret it based on these variables. As the time increases, the water level decreases. Increasing versus decreasing. In order to understand increasing versus decreasing, we need to be able to read the graphs from left to right. So on our first function on the left, an increasing graph will start from the bottom left and work its way up. This would be an example of a y equals x graph. A decreasing graph. If we're reading from left to right, the line would appear to slant down towards the right. This would be an example of a y equals, let's say, negative x plus 10. And we'll understand what the plus 10 means as we progress further in some of the other units. The example on the right is a constant rate of change. In other words, it's not going up and it's not going down, it's remaining constant. And so this would be an example of a y equals 3 equation of a line. Remember that if we have an x equals 4 equation, which we haven't really seen other than in some of our examples of our vertical line test, that those will fail the vertical line test and thus be not functions. So we really don't need to worry about any x equals equations right now. Our primary focus will be f of x or y equals equations. So a y equals 4 equation would give us a horizontal line like we see with the constant example. So we also want to be able to describe where the function is increasing, decreasing, or constant. And we're going to state each by describing the change in x values. So for this particular function, I might say something like The graph is constant from x is -5 to x is 2. The graph is decreasing from x is 2 to x is 3. The graph is increasing from x is 3 as it continues to grow. The reason I say as it continues to grow is because it has an arrow at the end, so it's going to go on and on and on forever. As you get into future years of math, you'll learn some more precise ways to state the increasing, decreasing, and constant. But right now, we just need to have an understanding of what's happening to the graph, and that precision will come as you get into Algebra 1. That should give you enough information to be able to practice on your homework. We will clarify any questions you have when we come back from the snow day. Have a good day. Bye.